Inheritance of quantitative characters, multiple genes. Many of the most important attributes of plants and animals, including man, cannot be adequately described as sharply constructing alternative characteristics. Rather, these attributes show as smaller and less striking quantitative characters like size, weight, and intelligent quotient. These quantitative variations are difficult to analyze genetically, since their phenotypic range is continuous without distinct steps that could be accounted for by distinct genes. In most cases, these characters show a normal distribution curve. Because of the distribution pattern, it was first believed that the small differences were due to environmental differences. Wilhelm Ludwig Johansen, a Danish pharmacist, botanist, plant physiologist, and geneticist in 1857 to 1927. He is the best known for coining the terms gene, phenotype, genotype, and for his 1903 pure line experiment in genetics. The work of Johansen in 1903 on the pure lines of beans showed that a population exhibiting variation of quantitative traits like seeds, weight, consisted a number of genetically different groups. His experiments explained that the continuous variation of quantitative traits was due to the effect of both genotype and the environment. This is the experiment of Johansen pure lines beans. One of the inheritance of quantitative characters is multiple genes. Multiple genes that control a trait act together to produce a single trait with a large number of phenotypes. Some genes have more than 2 allelic forms, which is referred to as multiple alleles. There are 3 people who explain about multiple genes. These are Yule in 1906, Nelson Ely in 1909, and Mather in 1943. George O'Neill, a British mathematician or statistician in 1906, he suggested that the quantitative characters are controlled by many genes, cumulative genes, or multiple factors of polygenes. Second is Neil Herman Nelson Ely, a Swedish botanist in 1909. He demonstrated in 1909 when he worked on the green color wheat, advanced the multiform factor theory or theory of polygenic inheritance, in which a trait is produced from cumulative effects of more than one gene. Traits that display a continuous distribution such as height, weight, skin color are polygenic. Kenneth Mather, the last one, a British geneticist and botanist. He proposed in 1943 the term polygenes to mean those genes with a small effect on a particular character, gene that can be supplement one another to produce observable quantitative changes. All the F plants are the same genotype, so that phenotypic differences would be due to a purely environmental effect. The average plant height in the F2 is 80 cm, which is the height of the F1. However, although the average height in the F1 and the F2 are the same, the variability would be very different in 2 generations. All the variability in F1 would be due to environmental influence, while in the F2 would be due to the both genotypic and environmental effects. And O'Neill say, in our laws of measurement, we frequently measure and O'Neill say, and the quote of O'Neill's in